Hello, everyone. I would like to welcome you to our presentation. We are Team Taffy by Ari, Ines, Isaac, Maggie, and Paula. Our client is Boxcar Coffee Roaster, which is dedicated to roasting different quality of coffee. Our contact is Mr. Charles Lambert. He is the wholesaler director of this business.
After talking to Boxcar about some of the potential problems they've been having, we decided to help them monitor the pressure within the chaff tube of their roaster. And this chaff tube can be seen on the left picture. It's that tube to the left of the big barrel, and it helps filter out all the chaff from the coffee bean the roasting process. So this chaff is kind of the extra bits of coffee bean and shells that aren't really used in the roasting process. So it filters these out from the roaster itself. And currently they don't have a way to measure the pressure within this tube, and they want to know the pressure so that they can see, how different factors affect their coffee, which is very sensitive. So if they can see the pressure that's in this tube, it might inform them how to better make their coffee. And currently they don't have any accurate readings. They only have good readings of temperature and pressure within the roaster itself. And if we take a look, you can see that's the tube right there, and then this is the roaster itself. And so we're going to help them put a pressure sensor basically on top of that tube that's going to send what the pressure readings are to a monitor that they can look at and see what the pressure is inside the tube.
Our two final printed circuit boards are based on these two Eagle designs. The design on the left is for the circuit with the pressure sensor, which is not a component placed directly on the board like the rest, but rather connected to this 3-pin header, which was also useful to design a casing that protected the circuit from the high temperatures of the tube in which the sensor would be placed. And the design on the right is for the receiving circuit with the LCD display. It actually shows an LCD screen half the size of the one we ended up using because the printed area wasn't getting calculated correctly. Although we did account for the larger LCD size, as you can see from the red dimensions when we were creating our CAD models for the casing.
This is the exploded view of the curved assembly, which will house the pressure gauge and the circuits for the pressure gauge, which will be powered by a USB cable so that the client does not have to worry about batteries. The circuit will be screwed into the separator piece that you can see in the middle, which will hold it in place. And there are pegs on the cover of the assembly so that the top can be securely lodged into the bottom of the assembly, and then the entire thing will be held together by straps, which will go around the pipe to hold it in place. And there will also be magnets on the bottom of the curved section, which will hold the assembly in place when you take the straps off to do maintenance on the circuit itself. This is the exploded view of the LED housing. This will house the LED circuit and the LED screen, which will display the pressure readings up to at the current time from the pressure gauge. The LED circuit will be held in place by screws in the main body of the housing, and the top will be held in place by screws onto the bottom. And the LED screen will be protected by a glass inlay so that nothing harms it. And the entire thing will be charged and powered by a USB cable so that the client doesn't have to go in and worry about replacing batteries in order to fix anything. And the entire thing is very small and compact so that it's easily storable and it doesn't take up a lot of room or make a hassle for the client.
This is our transmitting component. It's using an Arduino Nano hooked up to a USB cable, and as you can see, it is attached to this pressure sensor. This pressure sensor is currently attached to a bike pump, so the pressure sensor is measuring the pressure in this chamber here, sealed off with a little Teflon tape, and then it is reading on our receiving end here. It's reading at 36 psi, and it's been running for a little over 1,000 seconds. This receiving end also uses an Arduino Nano. What's special about these two components is using the NRF24 chips right here and right here. That makes it so these two can talk wirelessly that they can talk wirelessly within the coffee roaster. This receiving end would be by their monitor that receives all their other data, and then this transmitting would be on the chaff tube with the pressure sensor inside the chaff tube. We decided it would be best that to power both of these, we're using USB mini cables to power the Arduino Nanos. This one on the transmitting end would just be a longer USB because it's hard to reach. We didn't want them to have to keep getting up to the chaff tube and changing batteries. Along with this receiving end as well, it is also using a USB mini, and that would be easy because the display is right next to their monitor display using other USB cables, so that would just be an easy plug-in with their current setup.